commissioning is always a good idea. With commissioning, whether it's a large system like we're at today or a small residential system, commissioning is a good idea because it helps you to make sure you have a baseline for your system, number one, and number two, helps you to prepare the system for normal operation. But what is commissioning? Well, the Google defines commissioning as taking a new piece of equipment and bringing it online to an operational condition. The same as what we're doing here to this PV array. There are just four actual key points for the commissioning process. One is you check the DC, two is you check the AC, three, you turn the power on, and number four, you make sure you monitor the system to make sure that it turns on properly and there are no faults. Sounds good, boss. For the DC test, it's very simple. You want to first do a tug test to make sure that the cables are firmly captured in the fuse holders. And it's not just a gentle tug, it's kind of like a tiger by the tail tug. You want to make sure that the wire is not loose. After you confirm that the wires are tight, then we're going to do a quick voltage test. A voltage open circuit test, make sure you have the proper number of string voltage, then the proper number of panels in a string, and also we're going to check the polarity to make sure the plus goes to plus and minus goes to the minus. After we check that, we're going to do a ground fault test. The ground fault test is very simple. It's just checking the plus and minus string voltage to ground to make sure there's no connection there. After that's done, you can go ahead and close the fuse holders and turn on the DC switch. You're supposed to turn the AC first, right? Not DC first. The inverter is powered from the DC side, and this is the opportunity for us to go ahead and check and make sure we have the proper grid standard set in the inverter, which for commercial inverters is UL480A and for residential inverters is UL240. So to access that, you need to go into advanced settings and be able to check the grid standard. In addition to setting the grid code and verifying the grid code, now's a good time to go ahead and set the date and time and the address on the inverters while you have the inverters up. Both of those become important later when you connect to your monitoring system. Next, we're going to check the AC. And you do the same thing. You do the wire test, the wire tug test, make sure everything's connected properly, connected securely, and then you're going to measure phase-to-phase voltage and phase-to-ground voltage. What about phase rotation? Don't we have to check that? Well, phase rotation is important, but our inverters don't really care one way or the other. However, some jurisdictions require that you have the phase rotation recorded and marked either inside a cabinet at the point of interconnect or inside the inverter cabinets. So if it was required, you can do a phase rotation test. Now you can go ahead and close the wiring box because all your work inside the wiring box is complete. Now you want to make sure you use a screwdriver to tighten the screws. But isn't it much faster just to use a drill? And it takes forever to put these stupid screws in by hand. You are correct, the drill is way faster, but with the drill it's much easier to cross-thread the screws and strip the screws. In addition to using only hand tools like a screwdriver, you want to make sure that you're tightening the bolts in a crisscross pattern, going from corner to corner and in the middles. So you want to put all the screws in first and tighten them down as a unit. If you don't, it's real easy to get the cover cocked off to one side with one bolt too tight, and because of the type of insulation and seal that we have inside, if you tighten up a corresponding screw on the opposite side of the cover, you can actually strip the screw that way. Can I turn everything on now? Yes, you can go ahead and turn everything on now. You've got the cover closed, you've verified everything. Start and turn the AC on first, and then turn on the DC. Okay, first you do the DC checks, which is tugging the wire, checking the voltage, checking the polarity. Then you do the AC check, and a ground fault test. And then you do the AC checks, which is the same thing, tugging the wire, making sure it's connected properly, and checking voltage line to line, line to ground. Then you can turn it, before you turn it on, you put the cover on. Then you can turn on the AC first, turn on the DC, watch the screen, make sure there are no errors, and in 5 minutes it should power up. You got it, you're ready to turn everything on. Thanks for watching, everyone. If you like this video, please give us a thumbs up or a like. Leave a comment in the comment section if you have any questions or concerns. And don't forget to subscribe because you never want to miss a video.